start now with hard water and soft water. Let us try to understand what is a salt water and what is a hard water. A sample of water which lather with soap, that is called as salt water. This water can be used for bathing purposes and also for washing clothes. A sample of water which does not give lather with soap is hard water, and this is unfit for washing purposes and bathing also. Now the question arises, why is there hardness in water? Hardness in water is due to the calcium ion and magnesium ion present in hard water. Now the soap is sodium salt of carboxylic acid having large number of carbon. Suppose we have got soap having 17 carbons, C7, then we have got H35, and then we have got COONA. This is the soap. When the hard water is containing calcium ion Ca2+. Now when hard water comes in contact with soap, we will get calcium salt C7, H35, COO twice calcium, and this will become here 2Na+. So sodium ion is out here and calcium salt is precipitated. It does not give lather with soap. Similarly, magnesium ion also will give C17, H35, COO whole twice Mg. Now, what are the disadvantages of hard water? Well, the hard water cannot be used for washing purposes, and at the same time, over a period of time, the inner surface of the boiler gets crusted with so-called Butler scale, which is largely calcium sulfate, calcium carbonate, magnesium oxychloride. The deposition reduces the efficiency of the boiler and also damages it. It is therefore necessary to render the water soft before it can be used. Now we have to see what are the methods of softening hard water. But before that, it may be known that hard water is of two types. One is temporary hard water, another one is permanent hard water. Well, the temporary hardness is due to the bicarbonates of calcium ion and magnesium ion present in water, that is CaHCO3 twice is present in water, which provides hardness. Similarly, we have got MgHCO3 twice. This is also present in hard water. Permanent hardness is due to calcium chloride and magnesium chloride. It is also present due to calcium sulfate and magnesium sulfate. So we have got two different methods of removing temporary hardness and permanent hardness. Temporary hardness can be removed by boiling the water. Now here we have got say CaHCO3 twice. This is present in hard water. If hard water is boiled, hard water is boiled. So temporary hardness can be removed by boiling water. CaHCO3 twice will give you calcium carbonate, carbon dioxide and water here. Similarly, magnesium carbonate MgHCO3 twice, that will give you MgCO3, carbon dioxide and water. Both of these calcium carbonate and magnesium carbonate, they are precipitate, they move out of water. When calcium ion and magnesium ion are removed, hardness of water is also removed. The main culprit ions are calcium ion and magnesium ion, they have to be removed. So here by boiling we have removed them as carbonates, calcium carbonate and magnesium carbonate. Secondly, the temporary hardness of The water can also be removed by adding washing soda. Here we have got washing soda, sodium carbonate, Na2CO3, and the hard water is containing calcium bicarbonate, CaSO3 twice. When sodium carbonate washing soda is added to hard water, we will get here calcium carbonate, which is precipitate. So the calcium ion moves out of water and water becomes salt. This will be here 2NaHCO3. Similarly, here also we have got MgHCO3 twice here, and we get Na2CO3. We will get here magnesium carbonate, MgCO3, and this will be 2NaHCO3. So in this way, calcium ion moves out here, magnesium ion also moves out of the water, and thus water becomes soft. Now, another method of softening the water by adding calcium hydroxide, that is lime water, and this is called as the Clark's process. We have got one process called as the Clark's process. Clark's process involves addition of slaked lime to hard water. Here we have got, in Clark's method, we have got slaked lime which is added to the hard water. Hard water once again contains CaHCO3 twice, and we add here calcium hydroxide, CaOH twice. Calcium bicarbonate is present in hard water, and slaked lime we are adding from outside here. You will get 2CaCO3. You will get here 2CaCO3, and water is given out here. So once again you find that calcium ion is moving out of the hard water, and thus water becomes soft. Similarly, we have got magnesium bicarbonate HCO3 twice, and here we also add slaked lime, calcium hydroxide. We get here CaCO3, we get here MgCO3, and 2 water molecules. So in this way you find that magnesium ion move out of the solution, thus making the water soft. After discussing how to remove temporary hardness, now we come to removal of permanent hardness. Permanent hardness is due to the presence of calcium sulfate, calcium chloride, magnesium sulfate, and magnesium chloride. It cannot be removed by boiling. The softening may be carried out by treatment with sodium carbonate. So washing soda can be used both for temporary hardness as well as permanent hardness. Here the permanent hardness is due to calcium chloride, CaCl2, and we add here sodium carbonate, washing soda, Na2CO3, calcium carbonate moves out here, and we get 2NaCl. NaCl goes into the solution and calcium carbonate moves out. Similarly, we can also write down equation for MgCl2, which will give us MgCO3. Same is applicable for calcium sulfate and also for magnesium sulfate. Here we are adding sodium carbonate, Na2CO3. We will get calcium carbonate out, and sodium sulfate goes into the solution, Na2SO4. Similarly, MgSO4, that will react with Na2CO3, and that will give you MgCO3. CaCO3 and MgCO3, they move out here, and we get here Na2SO4, which goes into the solution. The main culprits for the hardness of water are calcium ion and magnesium ion, which can be removed by adding washing soda. The removal of both temporary and permanent hardness can be effected by ion exchangers. Well, we have got another method of removing permanent hardness, and that is zeolite or permutate process. By passing the hard water through a column of zeolite or hydrated sodium aluminium silicates called permuted process. NaAl, NaAlSiO4 3H2O. Due to the exchange sodium in the silicate, zeolite gets exchanged for calcium ion and magnesium ions and the water gets softened. So here we have got 2NaAlSiO4. 2NaAlSiO4 and here we are adding calcium ion Ca2 plus. We get here CaAlSiO4 twice and the sodium ion goes into the solution and calcium ion is held by the zeolite or permutate. Similarly, we can also write down the reaction with magnesium, which will give us MgAlSiO4 twice and 2Na plus. The zeolite oblique permutate can be regenerated by treatment with sodium chloride solution. Next method of removing the permanent hardness is by adding synthetic resins. Hard water is mostly softened by using synthetic cation ion exchangers. They are more efficient than zeolite and permutate. These cation exchangers are large organic molecules containing sulfonic acid RSO3H groups. The ion exchange resin is first changed to the sodium from the treatment with sodium chloride solution and then used for softening of water. 2RNA, here we have got 2RNA with a positive sign and here we have got M2 plus. That will give you R2M. That will give you R2M plus 2 sodium ion. So this is the way ion exchange take place, where M represents the calcium ion of the magnesium ion. M is either calcium ion or magnesium ion. The resin can be regenerated for further use by treatment with NaCl solution. Pure demineralized, that is deionized water free from all soluble material is obtained by passing water successively through a cation exchanger in the hydrogen ion form and an anion exchanger in the form of OH minus of cation and anions here. In the first exchange, hydrogen ion exchanges for calcium ion, Mg2 plus, sodium ion and other cations present in water and it becomes acidic. In the next exchange, anion like Cl minus, SO4 2 minus, HCO3 minus, etc. are replaced by OH minus, which neutralizes the hydrogen ion set free in the first exchange. The water becomes neutral. The cation and anion exchanger resin beds, when exhausted, are regenerated by treatment with dilute acid and sodium hydroxide respectively.